Hello everyone, my name is Anton Pelcher, I'm an engineer and I build fish farming facilities for more than 10 years. In my nearly 15 years of experience, not only have I personally built dozens of industrial farms, but I've also visited hundreds of other fish farming facilities. Honestly, I don't remember exactly how many there were, but it was a huge number. These included the USA, China, Iran, Europe, many countries, Germany, Norway, Denmark, Finland, Sweden. These were also CS countries. And here's what I noticed. Sometimes I would visit farms where it was clear the owner was saving money, but doing it so wisely and carefully that everything still worked. The farm ran like clockwork. But there were situations where people tried to save money in the wrong places, and just because of one or two trivial things they cut costs on, the whole farm simply wouldn't run. And this doesn't happen just here, in fact it happens basically all over the world. And sometimes it didn't just end in a trivial way, not just with a lack of progress and failing to meet the farm's planned targets, but with much worse consequences, even up to the loss of the entire fish stock. So today, I want to talk to you about a very important topic: saving money on fish farms. Be sure to watch this video until the end, because today we'll figure out what you can save on when building a fish farm without causing any harm, and what you absolutely must not cut costs on, because as soon as you do, you'll immediately run into a whole bunch of problems. So if the topic of reducing capital costs on a fish farm is relevant to you, give this video a thumbs up and let's get started. Let me start by recalling a specific, memorable incident from the very early days of my professional career, which likely took place all the way back in the year 2013. Some entrepreneurs from Georgia reached out to me. They built a sturgeon farm in Batumi for 50 tons of marketable product, I remember it clearly. And something just didn't work out for them. They tried to get it up and running, but it didn't take off. So they started looking for someone who could help them figure out what exactly was wrong and help reconstruct the farm. Well, we talked, got acquainted, and the conversation went well. And after some time I flew out to see them. They invited me over. I arrived in Batumi, they met me, everything was great, and they took me straight to the facility. And what I saw there honestly shocked me. Imagine a big, beautiful hangar, impressive metal structures, everything built solidly. They built concrete pools, very cool, everything poured, the floors, the utilities. Overall, from a construction standpoint, everything was done well, but when I approached the equipment and saw it, I was honestly in complete shock. The very first thing that I saw there was a clever homemade drum filter. Basically, it is just some kind of large cylindrical drum, which was apparently salvaged from an old washing machine, covered with a fine mesh and spinning on some makeshift rollers all the time. And some water is being poured over it. So it looks like a drum filter, but it doesn't really work. The next thing I saw was biofilters with sand. Instead of floating media, they used sand. And yes, a sand biofilter is a real technology, it works and all that, but it just wasn't quite right there. It was implemented there. Basically, those didn't work either. Alright, I thought, I'll move on. I went over to the disinfection units. The disinfection units turned out to be Chinese lamps ordered from AliExpress, just stuck randomly into the channel, and they exploded immediately during the first startup. Well, probably the only things that actually worked there were the pumps and oxygenators, because it's pretty hard to mess those up, homemade pumps. It's hardly possible to mess those up. Everything became even clearer when I started to look into all this in detail. On top of that, the pipelines that had been installed were also skimped on. They were too narrow, so they couldn't provide proper water circulation. So how did it all end? It ended with us having to reconstruct the entire farm. They probably spent about half a year on it. The concrete was broken up, the biofilter tanks were cut out and redone, everything that could be salvaged was kept, what couldn't be was thrown out, drum filters were replaced, and the disinfection systems were changed. In short, there were a lot of changes made there. It cost a pretty penny, and it took a tremendous amount of effort, maybe even a bit more than that. In the end, the farm started working. Yes, it really did function, and everything was fine with it. But unfortunately, the fact that they had to stop everything, lose a ton of time, look for specialists, and then redo everything, well, that completely ruined their finances, really set them back a lot, I would say. Why am I telling you all this? It all comes back again to the topic of saving money. There are things you can save money on, and there are things you absolutely must not cut corners on. And now I want to present to you a list of the top 10 things you absolutely should not try to save money on. All of these points will be explained. I'll explain why you need to do this, because all of these things are essentially the result of my own hard-earned lessons from nearly 15 years of work, as well as things I've seen on other projects, mistakes I would never want to make myself, nor see you make. Alright, let's get started. And by the way, if you're already familiar with the topic and The things I'm talking about will resonate with you, you'll understand them, and you'll know many of them already. Write about it in the comments and also share anything you'd like to add to my list. That would be very important to me. And the first thing is water exchange. So what is water exchange? Basically, it's the rate at which water is replaced in your fish farming tank. That is, 1 water exchange per hour means that the entire volume of water in your tank is replaced in 1 hour. 2 water exchanges means it's replaced in half an hour, 3 water exchanges in 20 minutes, and so on. That is 3 water exchanges per hour. I started out by designing systems with 1 water exchange per hour. Honestly, I admit it. Why did I do it? Well, probably not out of malice, but because, according to the calculations, especially on a sturgeon farm with a low stocking density, about 50 kilograms per cubic meter, all the calculations showed that everything would work as it should. On trout farms too, with low stocking density, it also seemed like 1 water exchange per hour. Experienced fish farmers, the old-timers, they told me, Anton, don't do it like that, you shouldn't. Do 2 water exchanges, 3 water exchanges, 5 water exchanges. Some said one thing, others said another. But I didn't really listen to them, I was just that stubborn. And why is that? Because the calculations showed that everything was fine, everything was good, there was enough oxygen. Ammonium nitrogen was being removed, everything was being removed, everything was fine. Why do more? Why install powerful filters? That would cost clients a lot, and so on and so forth. Well, in the end, I paid the price for it myself. What does water exchange do? It removes carbon dioxide from the water, eliminates pollution, removes organic contaminants in the form of ammonium nitrogen, and supplies oxygen for the fish. And even if, according to the calculations, everything seems to be fine, life makes its own adjustments. Life needs a serious margin of safety. And as long as you don't have that margin, your system will constantly be teetering on the edge of problems. Slightly overfed, problem, something a bit off here, problem, something a bit off there, problem. And most of these problems are solved simply by increasing the water exchange. How do I do it now? Now I do it very simply. If it's for sturgeon, I do 2 water exchanges per hour. If it's for trout, I do 3 and sometimes 4, especially for fry and larvae, water exchanges per hour. Basically, practice shows that these water exchanges work perfectly. Filter capacity reserve. The 2 main facilities on your RAS fish farm are the mechanical filter, drum filter, and the biological filter. You should never choose undersized filters. If there is an increased amount of suspended solids and you use these filters, everything just gets blown out and you immediately can't maintain the necessary water exchange, you can't maintain the required water exchange. Underfeeding occurs, problems, stress, in short, nothing good comes of it. That's why I adopted a golden rule for myself. For both mechanical and biological filters, I always allow for at least a 30 or even 40% margin. As soon as I started doing this, all the problems disappeared on their own. Pipe diameter. If you can add more media to a biofilter and with a drum filter, well, it's expensive, but you can replace it or install a second one or add something else. But pipes are something you install once, and after that, there's practically nothing you can do with them. Because once they're laid in concrete, if you miscalculated or made a mistake with their diameter, sorry, your only option is to lay new ones on the floor and then trip over them during COVID. The diameter of the pipes is also one of those mistakes I've encountered, and it's the issue I've seen cause the most problems at other fish farming facilities. That's why I strongly recommend that you always plan for proper water exchange and take into account the flow rates required in the separate drain collector and the separate motor collector. The quality of drum filters and biomedia. Oh, how many times have I seen issues with this? And honestly, I've run into them myself. A lot of people have this opinion, like, let's just make the drum filters ourselves. What's the big deal? The body, the drums, washing machines. Attach a motor, set it up, it spins, water flows through it, everything seems fine. But it's not that simple. Even if you have your own serious stainless steel or plastic production, and you seem to account for 90% of everything needed, you'll definitely make mistakes in the remaining 10%. And as a result, you'll spend the next year finishing, reworking, and dealing with problems with this filter because of that 10%. Personally, I'm in favor of making things like oxygenators, tanks, reservoirs, and pipes yourself or buying them. But when it comes to things like drum filters, I would strongly advise against making them yourself, because even if it turns out well, it's really a one-off case. Let's also talk about biomedia. I mean, what's the big deal with those plastic noodles, right? What special properties do they even have? Then why does it cost so much per kilogram? Why don't I just cut up some corrugated pipe myself or use bottle caps from Coca-Cola? Well, it might look the same on the outside, but it won't work the same because biomedia has a whole range of parameters: surface area, protected surface area, how it gets colonized. And that's my recommendation to you. Don't skimp on biomedia either. Never under any circumstances cut corners on the surface area of your biomedia. Always calculate it carefully. Oxygen source. Once I saw a solution at another farm that I really liked, and it was being heavily advertised as something super effective. It was a low-pressure oxygenator that worked together with an oxygen concentrator, just a regular, inexpensive medical concentrator. They told me, man, this is it, our solution is awesome. So what was the result? The result was a complete disaster. I implemented this solution on a couple of projects where each pool had its own oxygenator and its own concentrator. I bought a bunch of these concentrators, made these oxygenators, installed them on the projects, and started running into problems. Because the oxygenator, the pump was constantly overpowering the concentrator. These concentrators kept getting filled with water, getting flooded and breaking down, and all I was doing was constantly repairing everything and trying to get it back in order. And these problems kept happening until we just switched to liquid oxygen. So, what's the point? Never skimp on oxygen sources. Either install a central generator that will provide high pressure, high reliability, and deliver oxygen reliably to all consumers, or use liquid oxygen. With these two options, I practically never have any problems. Ventilation. I remember once I visited a sturgeon farm, I can't even recall exactly where it was, and I walked into the hangar. I remember it very well because I saw a rather run-down operation. Rusty columns, rusty equipment stands. We walked around the hangar, took a look, and then I asked, "So, how old are your first ones?" I thought I'd hear something like 10 or 15 years, but they said, "They'll be 4 years old." Honestly, I was completely shocked. Why? Because everything metal they had there was in terrible condition. The room was very humid, water was running down those stands. That's when I realized what the problem was. And the problem was that there was absolutely no ventilation in that hangar. I mean, there were a couple of vents, but that was basically it. No supply or exhaust ventilation, nothing. So what happened? Inside, the humidity was extremely high because none of it was being removed, and there was carbon dioxide, which caused even more corrosion. And because of the lack of ventilation, his entire operation was in truly terrible condition after almost 4 years. Why am I telling you this? Because I also don't recommend skimping on ventilation. You can make it simpler, but I don't recommend abandoning it altogether, because in the end it will ruin your main assets. So ideally, install a supply and exhaust ventilation system, at the very least just a basic supply and exhaust system with air exchange at least twice an hour. And then you won't have problems like these. Reliable power supply. Well, this is actually my favorite topic. I've seen so many times how just a simple voltage surge would break something, burn something out, the control panel would burn out, equipment would get fried, things would reboot, everything would freeze or hang. And then there were times when the electricity would go out and there was no backup power supply. In short, I've seen just about everything when it comes to electricity on my VPU. Here's what I've realized. Every farm absolutely must have two key things without which it's better not to even start. The first is a backup generator that will automatically turn on instantly if you lose power from the main grid. And the second is a voltage stabilizer. Never connect expensive equipment or control panels directly without a stabilizer, because as soon as there's a power surge in your electrical network, something is bound to burn out. A cheap hanger with frequent columns. Currently, the main technology for building hangars is to use a load-bearing frame onto which sandwich panels are mounted and so on. In order to reduce the weight of the metal structures and make the hanger cheaper, designers will often suggest placing the columns more frequently. Well, it seems like it's not a big deal. They'll just put the columns closer together. Alright, fine, once again, every 6 meters. It's inconvenient to install equipment, but it's acceptable. But if it starts being every 4 or 3 meters, then that's a complete... I won't say what exactly, because as soon as it comes to installing pools in your nuclear core, practically nothing can be done. You'll have to make compromises, reduce the diameter of the pools, use the space less efficiently, and so on. That's why I recommend you not to skimp on columns. Make the spans at least 9 meters and preferably 12. In general, it's good to have a column-free span. Obviously, everything comes at a price. You always need to find a balance, but I also don't recommend placing columns every 6 meters, and certainly not more frequently. And another one of my favorite topics is the automation system. I've seen so many situations where pumps sucked all the water out of the pump sump, started drawing in air and burned out. About how the cushion would get pushed out in the oxygenator. about how the system would just stop for no reason, about how all sorts of strange errors and malfunctions would occur, and so on. With the automation system, I've seen a huge number of problems. So here's my recommendation. On the one hand, don't install something expensive, complicated, and super high-tech if you don't know how to operate it. But on the other hand, don't just put in a simple plastic panel with a single circuit breaker that you flip on, which won't be able to shut off the pump in case of problems or help you understand anything. I mean, I recommend looking for an optimal solution when it comes to the automation system. At the very least, you should have basic level sensors in the pump sump, dry run sensors, and pressure sensors in the pipeline. You should also have emergency alarms installed, so that at least the system can understand some basic things and send the correct signals to your equipment. And of course, you should also have backup equipment in case of burnout. Well, we've just gone through it together. The top 10 areas where I absolutely do not recommend cutting costs, where everything needs to be organized very carefully, because saving money in these areas will come back to haunt you. Now let's move on to the most interesting part. So, where can you actually save money without running into trouble? And the first and most obvious thing, if you want to reduce capital investment, break the farm into modules. That is, you don't need to make one big module and only part of the pool for it. Divide it into independent filtration systems. You can launch one line, say, now, and leave the second line for later, exactly the same as the first. You don't have to launch the incubator right away. For example, you can start by working with ready-made fingerlings. That is, launch a separate production line for growing market fish, which you can later scale up and add to. The incubator can be added later, so your farm becomes like a Lego set. This is not only possible, but necessary to do. The next thing is to build the pools yourself. For example, when it comes to a drum filter, I absolutely do not recommend making it yourself. It's better to buy it from someone who has been manufacturing them for a long time. But pools are essentially just containers. This is the kind of thing you can easily make yourself. But not just anyway. You need to build it according to properly designed, pre-made blueprints. Because a pool is not just a barrel. This barrel has a water supply, it has the correct water drainage, sewage disposal, and fish release. In other words, this barrel is connected to an entire network of supply pipes, specific sumps, hoppers, and so on. In order for the pool to function properly, you need competent blueprints, plus a team that's ready to work for you. You can cast the pool from concrete or weld it from plastic, and then you can easily build them yourself. You can install the line on your own without hiring someone to do a turnkey job. It's absolutely doable. If you have an equipment supplier or a designer who can provide you with an engineer, hire your own crews and have them install the technological line under the engineer's supervision. As a rule, this will be cheaper for you than hiring an organization to do a turnkey job. This kind of savings is entirely possible. Again, with the caveat that these shouldn't be just any people. At the very least, they should be professional plumbers who can join pipes, glue, solder, work with plastic, and so on. And if we're talking about plastic, specifically sheet polypropylene, then you need specialists in polypropylene who know how to weld it. Install the basic minimum of equipment. Well, an automatic feeding line, a monitoring system that measures 500 parameters, automatic fish movement and sorting. Of course, all of this is great, but if your budget is limited, you can easily do without it. In other words, you can set up the basic minimum of equipment, filters, and so on that will keep your system running, but at the same time won't hit your wallet too hard. Rent liquid oxygen instead of buying generators. At any intensive fish farming RAS facility, you need pure oxygen. You can buy generators that will produce this oxygen for you on site, or you can go to a company that supplies liquid oxygen and rent a tank from them. And they will simply come and refill the tank for you periodically. Both solutions are perfectly viable. But in this case, you won't overpay for the equipment itself. You just rent it, and that way you'll simply pay for the oxygen as you go. This way you can reduce your expenses by not purchasing generators and opt for a cheaper building technology. If you need to save money on the building, it's better not to install columns every 3 meters, but instead change the construction technology of the hangar. For example, switch from expensive sandwich panels to, say, more affordable sandwich panels, or even to a frameless hangar. That is, you can install an arched hanger, spray polyurethane foam on the inside, and basically it will work as well. Yes, of course, hangars made with sandwich panels are better, but it's better to do it this way than to save on things you shouldn't. For example, build a hangar out of foam blocks if foam blocks are inexpensive for you. That is, analyze the building construction technology and possibly find a cheaper option, as long as it doesn't interfere with the layout of the internal equipment inside the building itself. And probably the last thing I'd like to mention is simplifying the floors. Yes, of course, it's great to have nice floors. A perfect poured slab, 20 centimeters thick, double reinforcement with a polymer coating, Trapic and all that. But if your budget is limited, you can do without all that. You can simply pour concrete footings under the pools to keep them from shifting, and in the spaces between, for example, fill with gravel and lay the utilities in that gravel. This way, you'll save a lot on pouring the floors. It's better to save here than to cut costs where you really shouldn't. So that's everything I wanted to talk about. If you found this helpful, give this video a thumbs up and subscribe to my channel. By the way, also check out this video. I also recommend checking out my Telegram channel because I do a lot more breakdowns there. This was Anton Pelcher with you. My channel is about how to farm fish and make good money from it. Bye.